these are our muscle fibers, fast twitch, slow twitch, and somewhere in between. This is what they look like, not that you get it. All right, now the last thing here, and this will help you understand and learn muscles, I hope. Some muscle fibers, well, let's get Willard here. He will make a good example for this. The organization of the fibers, parallel, convergent, uni, bipennate, multipennate, circular. This can help you understand basically organization of muscle fibers. So here's how this works. Let's do circular first. These types of muscles are called orbicularis muscles. And the two in the body that are probably most easiest to understand, and you can see right on Willard here, are the orbicularis oris and the orbicularis oculi. All right? Oculi, right here, the circular muscle around the eye. Orbicularis oculi. The muscle around the mouth, the orbicularis oris. They're round. Right? You can see them. They look, the fibers are round just like that. Oops, where is it? Just like that. So this is the orbicularis. How about here, convergent, pectoralis major. See that one up at the top? There's a common tendon, but a long fan of muscle, and it inserts right here on the medial border of the sternum. Right? So those are called convergent muscles. Lots of muscles in the body are parallel. The fibers run parallel to one another. The biceps. Most of the muscles in the body are parallel. So parallel muscles. And then others like the rectus femoris. Looks like, you know, the fibers are all converging towards the central tendon. Or this one, the extensor digitorum, looks like a feather. Right? They're all converging in this direction. Or here's a multipennate, the deltoid muscle. Right? So if you understand a little bit of this terminology, it will help you understand maybe where some of these muscles are and the organization of the fibers. So that, I think, is pretty kind of important terminology here, something to learn. And the very last thing about muscles, and I will not stress this at all, there's only one thing to take away from this, is that all the muscles in the body work by leverage. Ultimately, that's how it works. And in the human body, there are three classes of levers, way in which force is generated. First, second, and third degree levers. Most of the important muscles in the human body work by third-class leverage. And here's the muscles and the leverage. First, second, and third. Third being the most common type of lever, or leverage in the body. When I taught this class at City College years and years ago, we had sort of a study guide that was made by Joyce Costello, who was at the time the lead anatomy instructor down there. And Joyce expected the students in the anatomy classes, although they didn't do it in my class, but you know, Joyce didn't care, I don't think, that you could actually calculate, i.e. math. Oh, ouch, math in anatomy? No way. You can actually calculate the leverage or the force applied at the various muscles, at the various joints. They didn't like to do that, so I just didn't do it. I don't think nobody ever came and complained. They said, well, you know, in so-and-so's class, they're calculating leverage and force. How come we're not doing it? And I just would have said, because I don't want to, right? And nobody ever argued with me and said, oh, please, I want to calculate leverage. And then, you know, if you want to do it, go ahead and then show me how to do it. Anyway, so first, second, third class levers. So we're not going to do any of that. Just remember the most common type of lever in the human body is the third class lever. And again, you can calculate. Sounds like a physics course. Is it a mechanical advantage or disadvantage? Again, we're not going to worry about that. There's a couple of pictures in your book that give you illustrations of of how the force and the leverage is exerted by various muscles, like nodding your head or something like that. This is again, you don't like start looking up in the book and go, okay, my God, there's 800 muscles in the human body, and now I've got to learn each one, is it a first, second, or third class lever? Just basically guess third class, and you'd probably be right. All right, that's what I do anyway. But the third class levers, most of the flexors, most of our muscles flex and extend. So you can see, the third class levers are the most common ones because flexion and extension at almost all our joints is the most common movement. So leverage. Again, I just had to mention it because it's in the book, but the third class lever is the most common type of lever found anywhere in the body. There's other examples, but there you go. Now, I think that's the last
Prime mover and antagonist.
Oh, God, yes, this is important. I need to mention this, the prime movers. This is real intuitive, though. Okay, think about this. Prime movers, synergists, and antagonists. Okay, so let's take the bicep, because this is an easy one. All right, but you can do them almost for any muscle in the body, the prime movers. The prime mover is a muscle which is responsible for producing an action to the joint. So the prime mover for flexion at the elbow is the biceps, right? That's the prime mover. But every prime mover has an antagonist, which basically controls, quote unquote, in a way, the action of the prime mover. So if flexion at the elbow, if the biceps is the prime mover, the antagonist is the triceps, right? But, okay, extension at the elbow, the prime mover is the triceps, and the antagonist is the biceps, right? Now, you don't have to know these for every joint. Of course you don't. But I think it's important to understand that certain muscles are responsible for a certain motion at a joint, but they always have sort of like a controller, right? So, okay, how about this? The extreme example. We're going to assume for a second that, you know, your triceps doesn't exist. Okay, so we're going to have problems here. We can do this, right? But now we have no triceps. Now we're stuck, right? What are we going to do? I guess we'll have to somehow just pull this down, right? That's obviously not going to work very well. So you get the idea of a prime mover and an antagonist, right? And they exist at all these joints. You know, flexion and extension at the wrist. You know, the flexion and extensions you're learning in the calf. Well, what about something called a synergist? A synergist, oh, and the other term, and you'll see it in the books a lot, for the synergist is a F-I-X-A-T-O-R, a fixator. That's the other term for a synergist. These are generally smaller muscles, which in a way will assist the prime mover. Maybe they help stabilize a joint, you know, temporarily or something like that to allow the prime mover to do whatever its prime motion is. So the synergists are usually just helpers, or the other word I said is fixator. So they just kind of help the prime mover in whatever action it's going to do. So so there's, you know, tons of examples in the body of prime movers and antagonists, but it's just important for you to understand that they do exist in groups. So what one muscle is doing, the other often becomes the opposite member of a group. Okay, so that's the idea of prime movers, synergists, and antagonists in the human body. That's those guys. Now, I got us through that. That's cool. Now, for the exam on Tuesday, coming up here pretty soon,